Hey everyone, welcome to the Spring 2024 Gauntlet Math Review. I'm Jen Carlson. First, let's get back to the basics with our desired over have times quantity, where the desired is the order, the have is what we have available, and the quantity is how we have that available. So for this order of amoxil 0.5 grams PO Q6 hours, I want to convert that 0.5 grams to milligrams first. So 0.5 grams is 500 milligrams. Then I do my setup, 500 milligrams over 250 milligrams times one capsule because I have available 250 milligrams per capsule. And I end up with 2 capsules as my answer for how much I'll administer. The next couple I'm going to have you try, so numbers 2, 3, and 4. Remember to round to the nearest tenth unless otherwise indicated, so I'll give you a few minutes for that. Okay, let's see how you did. So if I want to give 7 milligrams and I have available 4 milligrams per 5 milliliters, I'm going to give 8.8 milliliters. If I want to give 0.6 grams and I have available 300 milligrams per 2 milliliters, remember I'm going to want to convert that 0.6 grams to milligrams first, and I'm going to give 4 milliliters. And then if I want to give 0.375 grams and I have available 250 milligrams per milliliter, again, I'm going to convert those grams to milligrams first, and I'm going to give 1.5 milliliters. Next, we're going to talk about programming the pump. So remember, the pump speaks in milliliters per hour. If you can remember that, that will tell you exactly what information you need to find out. So if I have an order to infuse 500 milliliters of 0.9% normal saline over 4 hours, and I want to know how I'm going to set my pump. First step is to figure out what information from that problem that you actually need. And I need that 500 milliliters and those 4 hours. Then I do my setup, 500 milliliters divided by 4 hours, and I get my answer of 125 milliliters per hour. That is how I will program my pump. Our next topic is intake and output. And remember, all intake and output has to be in milliliters. So if you're given this problem with a list of things that are either intake or output and they're kind of all combined, first make a column of intake and a column of output. And again, remember, all of that needs to be in milliliters. So the first one for intake, we have 1200 milliliters. It's already there. You're good to go. Next, we have 1 cup of coffee. So we need to convert that. So remember, 1 cup is 8 ounces. And then ounces times 30 equals milliliters. So I end up with 240 milliliters of coffee. And then I have 24 ounces, again, 24 ounces of water. So again, 24 ounces times 30. And that equals 720 milliliters. And then 3 teaspoons. So 3 teaspoons times 5 equals 15 milliliters. So that's my intake. Then for output, I have 20 milliliters of vomit, 1.5 liters, so I'm going to convert that to 1500 milliliters. And then I'm going to have 750 milliliters of diarrhea. Add each column. So my total for intake is 2,175 milliliters, and my total for output is 2,275 milliliters. Next, we're going to go on to tube feeds. So there's 2 different types of tube feeds that I'm going to talk about. One of them is where you are given the final volume. We're going to start with that first, and then the second one we're going to talk about, you have to find the final volume. So if you are given the final volume, and I want you to kind of look at these and note how the question is set up so that you can tell whether you have the final volume or whether you need to find it. So here you're given the final volume. Prepare 2/3 strength Sestical, 300 milliliters, that's your final volume, PO, QID, how much formula will you use, how much water will you use. I like to do the step 1, step 2, where step 1 is the strength times solution equals the solute, and step 2 is the solution minus the solute equals the solvent. The solution is the total volume, the solute is the med, and the solvent is the water. So step 1, 2/3, that's my strength, times 300 milliliters, which is my solution or my total volume, equals 200 milliliters of formula or solute, which is your med. Step 2 is that solution, 300 milliliters, that's my total volume, minus my 200 milliliters of solute or formula, med, however you want to call that, equals 100 milliliters of solvent, which is the water. Now remember, when I say water, sometimes it's not water, but that's the most common. Water is going to be whatever additive you are putting into the formula. Next, we have the tube feed where you have to find the total volume. So you have an order for a 3/4 strength Sestical tube feeding. The formula comes in cans containing 340 milliliters per can. How much water would you add to mix this? Okay. So first we need to find out 340 milliliters is 3/4 of what? Okay. That's like our first step here. So we multiply by the reciprocal, and by reciprocal, I'm going to take that 340 milliliters, and I'm going to take my strength and flip it. That's what I mean by the reciprocal. So 340 times 4/3. So here I'm going to set it up just like I would, a dimensional analysis problem or something like that. And I'm going to multiply straight across the top and then straight across the bottom. Don't cross multiply here. Okay, so straight across the top, 340 times 4 equals 1,360, and then 1 times 3 equals 3. And then I'm going to take that 1,360 divided by 3, and I get 453.3 milliliters as my total volume. Now that I have that, I'm going to go straight to step 2 from the previous slide. So 453.3 milliliters minus 340 milliliters, which is what my formula amount is, and then it gives me 113.3 mLs of water. Next, we're going to talk about reconstitution. So reconstitution, if you are given a label, it really is just all about reading the label. So first, how much diluent must be added to prepare the solution? Read the label. So right here, it tells you to add 140 milliliters of water. That's my diluent. What is the volume after preparation? Here it tells you it will make 200 milliliters of suspension. So my total volume after preparation is 200 milliliters. And then my final concentration, that's right here. So this might look different depending on the label. For here we have 200 milligrams per 5 mLs. But just know if it's not right there on the label, it might say something like each 5 milliliters will contain 200 milligrams once reconstituted or something like that. Read your label. A lot of times when we go to that final concentration part, people make something up because they're not really sure, or they'll do something with the diluent in the final volume, like 140 milliliters in 200 milliliters. And if you think about it, you're just taking some numbers that you see and putting them together. That doesn't even really make sense. So read through the label, because I promise that it's going to be there. It just might look a little bit different with each different label. Just take your time. So number 10, this is another reconstitution where I don't have a label. I'm just given instructions. So I have an order for 500 milligrams, and it tells you what's available: a vial with 2 grams of powder, reconstitute with 19.2 milliliters normal saline to equal 100 milligrams per milliliter, and how many milliliters will you administer? So this looks like you have a lot of work to do, right? But just think about what the question is asking you. I'm going to use desired over have times quantity. The rest of the information here is just fluff, and I see that a lot. And a lot of people want to make it more complicated than it is. Figure out what the question is asking you. So here I just want to know how many milliliters I'm going to administer to give this dose of 500 milligrams. So I'm going to take my desired over have times quantity. So 500 milligrams as my desired, that's my order. And I have available 100 milligrams times 1 ml, or per 1 milliliter. And I get 5 milliliters. That's it. Then we have drops per minute. So use this formula. X drops per minute equals your total volume in milliliters times your drops per milliliter times, or divided by your time in minutes. You can use this formula for any drops per minute question that you have. Even if you're not solving for drops per minute, just say you need to solve for like how much time will this run over, or what is your total volume. Just use the same formula and place X wherever you need to solve. So for number 11, your order to administer 500 milliliters of 0.9% normal saline over 12 hours using 15 drops per milliliter tubing, and you want to find the rate of administration in drops per minute. So first you want to find your time in minutes, so 12 hours times 60 equals 720 minutes. Then set up your formula. So X drops per minute equals your total volume, which is 500 milliliters, times your tubing, which is 15 drops per milliliter, divided by your 720 minutes, and you get 10 drops per minute. Next, we have weight-based dosing. So first thing we want to do for this, we have an order to give 25 milligrams per kilograms per day in 4 divided doses for a patient who weighs 52 pounds. So find your weight in pounds. So 52 pounds divided by 2.2 equals 23.6363, and so on. Use that weight for your equation. Don't round until the very end. So now I want to multiply by 25, so 25 milligrams times my kilograms. So I get 590.9 milligrams per day. Next, I need to divide that by 4 doses. That gives me 147.4 milligrams per dose. I know that we're not in the habit of labeling until the very end, but I always say to label all the way through. That way you don't get confused as to what exactly you're looking at. So 147.7 milligrams per dose. And then I'm going to use that in my desired over have times quantity to solve. So 147.7 milligrams over 150 milligrams times my quantity of 1 milliliter, because I have that vial, that bottle that's labeled 150 milligrams per milliliter. The fact that it's a 100 milliliter bottle is not significant. That's just some fluff there. And it gives me 0.99. Round that to 1 milliliter per dose. And then I have safe dose range. So if I have an order for 350 milligrams BID for a patient weighing 9 pounds, and then I'm given a therapeutic range. First, find your weight in pounds again, in kilograms again. So 9 divided by 2.2, so 4.090909. Use that weight for both equations. Don't round until the end. So first I'm going to take the low end of the range, which is 150 milligrams. And that gives me 613.6363 milligrams per day divided by 2 doses, so 306.8 milligrams per dose. Then I need to take my weight and multiply it by the high end of my range, so 300 milligrams. So I get 1,227.2727 milligrams per day, divide by my 2 doses, and I get 613.6 milligrams per dose. So my safe dose range here is 306.8 milligrams to 613.6 milligrams per dose. You could take your your total milligrams per day and make that your range, and that would be your safe dose range per day. But then you would still need to divide those both by 2 doses per day to find out what you're going to give. So the order is for 350 milligrams per dose. This does fall within my range, so it's safe. And that's it for our math review. If you have any questions or if you need tutoring or anything, you can contact me. It's jennifer.carlson@eac.edu. You can also send me a text. You can come down during my office hours, but I always ask that you let me know in advance that you're coming so that way I can prepare something for you. So like I said, let me know if you have any questions. Your math packet that you got to go through all of this does have an answer key at the back, so you can work through that and check your answers. And good luck this semester.